Okay, angular size does matter, and that's what this sign here says, this little text. And so does this one. It says the same thing. So you can see the big difference in how we resolve it with our eyes. It's not resolved very well due to the angular size. On this one, I want to bring to attention a bunch of the little smaller details that I see in it. And we're going to start out with just this zoomed back shot here. Now there's going to be a fish that jumps out here, and I'm going to slow it down, and I'm going to point an arrow right toward it. And now you think I could see this with my naked eyes from where I'm actually standing at? No way. It's just too far away. So of course my naked eyes can't see it. So was that over the curvature? Of course not. But I could see it zoomed in on it with a camera. And that was a mighty big fish. Also, you see this dolphin out there. I've caught these dolphins up in the mirror line, or that mirage line, and that's what I'm going to bring out too, some of this mirage line and what it means. And there's people that say that waves don't block out distant objects, and this mirror line doesn't mirror the sky. Well, we're gonna kind of show that that's not true, because the water that is above this visible water line is actually a mirror, and it mirrors the sky. And later on in some of my other videos, we'll be able to show it. On this particular day, I did what was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 videos. Actually, there was 14, but one was real short. I didn't have really much on it, so I deleted it. It wasn't even in focus. And sometimes that's another thing, because of this angular resolution, being that I'm so close to the water, I cannot focus it really well through this small viewing screen that I've got on my camera. Now watch these boats, and watch the wake that it makes, and you can see very well, very easily, that it blocks out Cutter's Rock. And also, man, this guy's smoking up a storm, man. He ought to fix his diesel engine before he pollutes the whole world with that thing. But you can look at this Cutter's Rock, and you can see that mirror line. Now, I'm not really good at editing videos and doing graphics on them, but you could draw a line there and show where that line was at, that mirror line. Now, these boats that are sitting closer to me, of course, you don't see that miraging, that mirror line. You can actually see the water running up to the edge of the boat. Now, you start getting into some of these further distance boats, and you can see that he's kind of right at the edge of falling off the world, or falling off the curve. But watch this one. He's actually got the water in front of the boat. He's riding in the air practically, and then if you look at the water line behind it, it is higher. Why? Because he is actually creating a wake, which is pushing up water and bringing it into resolution into my camera. My camera can resolve it because it's lifted up. It's being pushed up by the boat's wake. So this is where you got two different water lines, but you see the front of his boat where he's appearing to be floating in the air practically. But you do see the water coming off of his hull there, or the front of his bow of the boat, pushing it up. And then as we continue to watch, you'll see some other boats come in here, and I like reviewing my videos in slow motion sometimes because I pick up a lot of the smaller details that, you know, we miss when we watch them at regular speed, or, you know, if we speed them up too quick, we lose that smaller detail that we should be really paying attention to. Um, and sometimes I'm zoomed in too much to even see that smaller detail. Um, but look at the difference in the water line. Just look at that, for instance. So is he riding on two different water lines, or uh, is that mirroring actually blocking out the water that's really in front of the boat? And that's what, you know, I try to show people, is that that mirroring, that mirage line, does hide um, other stuff beyond. So does his wake, his waves. His waves that block out the lower part of this boat. Look at that. And, you know, those wakes ain't coming up that high. But now watch this. Here's something cool. If you've seen that boat come in from the right side, and I'm going to start following this little sucker, you could actually see the boat, but it's being like compressed down. Now, when he gets back here where that boat went by and created the wake, he almost looks like he gets pushed down. And that's the downward refraction that we're always talking about. Or you could even say it's a diffraction line where it's being diffracted downward, or being blocked out by diffraction. So as I follow this boat, you know, I start noticing how there's this little yellow spot in front of it, and I think it's because it just cannot resolve what's actually there. And then here too, when these boats go by, you can see its wake block out some of that boat. It's a wave blockage, but when it's in this mirroring line, when it's beyond the mirroring line, that water cannot be resolved. So it's just the mirror, because of the angular resolution that I'm at. I'm at a low angle, and this is a very, very low tide today. So I've got all these rocks sticking out, which, you know, also blocks out the bottom holes of the boats, just like the waves would in some of the previous videos I sent or I made on this day. And I'm going to make videos, you know, single videos for each video I did. So you could watch, I think it was like 2.5 hours or 2 hours or something like that. You can watch them individually. But now watch as this boat gets a little closer and it starts to come into resolution, and we're not getting as much of a wake blockage or a mirror blockage. The mirage line, the mirror line, is what actually causes, I do believe, like the downward refraction effect. It pulls things down. It doesn't lift things up, which, you know, that's where, you know, science is trying to get us all to believe that this thing is beyond the curvature of Earth, but it's because of angular resolution is why we cannot perceive the whole boat. Now, all of a sudden, boom, pow, there it is. Here's the boat coming in on an angle, and you see the rear end of the boat is still back into that angular resolution where it can't really get resolved. But you can see that it's the whole boat. And as I follow it, you can even look at this pole and see kind of how that diffraction is. So I'm going to keep following this boat until it comes up to the visible water plane. Once it gets on that visible water plane, it is very easy to see the whole boat in the water. But this boat does something else too. As it gets up here, it'll stop. And when it stops, I want you to pay attention to that mirror line, that mirage line, because you'll see him like kind of sink down in the water, but he's still in that mirage line. So he will literally like get sucked back down into the mirror. Yes, of course the boat is stopping and he's sinking back down in deeper, but you know, this is how this mirage line works. You know, you can see that the undercarriage of his boat because he's up on plane, and that's also could be the water being pushed up and we being able to resolve it. But you can see the water now that the boat's pushing up. We're able to resolve it because it's high enough for my camera to resolve it. Here he goes. He's going to shut down, and again he sinks into that mirror. He sinks into the mirage line. Now, the good thing about this is we got some sunlight shining on the back of his boat so we can resolve it, but you can still see the mirroring going on just underneath the back side of that boat. And also, we can take into consideration looming, magnification due to the water molecules in the air creating a magnification. That's also, the looming. Rob Shakiba did a great job in showing how looming can affect things and cause things to get cut off too. So I think it's kind of a combination of the looming too and this miraging, this mirror line. Angle of light is also something that we need to take into consideration. And I'll bring that up in the next video, that angular angle of light causes different effects, and really this downward refraction, people want to laugh, or the globe people want to laugh, and the trolls want to come on my channel and tell me that my videos are proving the curve. Well, that's just because they have no knowledge of what mirroring is or what miraging actually is. And unless you go out and do a whole lot of observations and you're really paying attention to these details, you're not going to see it. Like this boat, watch his wake. He's going to cover up the other boat. He's going to block that other boat out with that wake. This is all due to because of the fact that that boat is much further past him. So here's my proof that waves can block out farther boats. Now, what about the waves that are up in that mirror line that you cannot see? And that's one of the big points I want to make. When you cannot see those waves that are up in the mirage line, it just cuts everything off. It totally blocks out the lower hulls of boats, lower hulls of buildings, objects, anything that's out there. It will totally block it out. Why? Because it gets sucked down into that mirror. It's really getting pulled into it, not being pushed up from it. Like I say, the mainstream science wants us to believe this, and we all have. I was a globe believer for most of my life until I started going out and doing my own observations and saying, how can this be? When I have great days of visibility, I can see things that I should not be able to see very clearly, without all the distortion and without all that, I mean, how can I say it? It's perfectly sitting in the water, just like a lot of these boats. And when I get an object that's out there 11 miles and I can see it, it makes me question what science says about a man standing on the shore at 6 feet tall. He should be able to see about 3.14 miles. Hey, 3.14 miles. What is that? That's pi, right? Pi. 3.14. So, are we being deceived? I think so. I think we're being deceived on a large scale on many subjects, and that's where we have to go out and we have to do our own science. And that's what I like about what the flat earth community is doing. Not only are we going out and doing our own observations and analyzing them and trying to solve these issues where the globe people want to say that it's one thing and we're proving that it's another, but they're never going to accept it. It's going to be a continual denial no matter what. Now look at that rack back there and look at the sign that's on that rack. Okay, that's going to be in the next video I bring up, so pay attention to the next one too. Ben and Taboo Conspiracy, you do great work, man. I know you can do something with this video. I'm not going to post it. I'm not going to make it um, public. I'm just kind of like, I'm frustrated at this point. Um, so whatever you want to use, brother, you can use it. All right. So and I appreciate you taking your precious time and doing work on my videos. Thank you very much. I appreciate it, Ben.